All right, welcome. Today we are going to crack the code on a pretty neat 3-mark algebra proof question from a recent GCSE maths paper. You'll see it's a perfect example of how to take a wordy problem and turn it into simple, clean algebra.
Okay, so here it is, the full question, right on your screen. We've got two bags, a mix of colored counters, and some rules connecting everything. I know, at first glance it looks like a lot to unpack, doesn't it? But don't worry, the real trick is just to break it down piece by piece. So what's our goal here? It's that final line. We need to prove that the total number of counters from both bags is exactly 4x. We're not trying to find what x is, we just have to show that this formula is true no matter what. That's the mission. All right, let's get into it. The very first step with any problem like this is to pull out all the essential facts. We're going to ignore all the noise and just laser focus on the bits of information we absolutely need to build our proof. Okay, so here's what we've got. In bag A, there are only red and yellow counters in a 3-to-5 ratio. And here's the golden ticket, right? The number of red counters is x. Then you've got bag B, which has half the total number of counters as bag A. And you know what? That is literally everything we need to solve this. So first things first, we've got to figure out the total number of counters in bag A, but we need to write it in terms of x. Honestly, everything else in this problem depends on us getting this first part right. And you know, this right here is the absolute key that unlocks the whole puzzle. That variable x isn't just floating around randomly. The problem explicitly tells us it's the number of red counters. And since the red counters make up 3 parts of our ratio, we now have a direct link. 3 parts equals x. This is what lets us figure out everything else. Okay, so let's walk through the logic here. If 3 parts are worth x, then it's simple, right? 1 part has to be x divided by 3. And since the yellow counters make up 5 parts, we just multiply that value by 5, which gives us 5 over 3x. So to get the total for bag A, we add the red ones, x, and the yellow ones, 5 over 3x. And that gives us a grand total of 8 over 3x. And boom, just like that, you bagged your first mark. The official mark scheme shows that this method, finding the total in bag A as 8 over 3x, is exactly what they're looking for. Okay, so we've got bag A sorted. Now let's use that to tackle bag B. So remember that other little detail from the beginning? The link between the two bags is super simple. Bag B has exactly half the counters of bag A. Even with fractions involved, the idea itself is really straightforward. All right, let's do the math. We take our total for bag A, which we worked out was 8 over 3x, and we just slice it in half. The easiest way to do that, just have the top number, the numerator. So 8 over 3 becomes 4 over 3. And there we have it. The total number of counters in bag B is 4 over 3x. And check it out. There it is. Straight from the mark scheme again. This second step gets you the second method mark. And notice that little dip in there? That means it's a dependent mark. You had to get the first bit right to get this one. All right, we're in the home stretch now. We've got our value for bag A, we've got our value for bag B. All that's left is to put them together and finish the proof. So the final step, the big finish, is just adding our two totals. We have to show that when you add the counters from bag A and bag B, it all magically simplifies down to our target, 4x. And this is that awesome moment where it all just clicks. You add 8 over 3x and 4 over 3x. The denominators, the bottoms, are the same, so you just add the tops. 8 plus 4 is 12, so you get 12 over 3x. And what's 12 divided by 3? It's 4. We did it, 4x. And that final, beautiful line of work, that gets you the third and final mark, often called a communication or conclusion mark. You've shown the whole journey, clear as day, from start to finish. That's a full 3 marks in the bag. But hold on a second. What if you didn't think about it that way? What's so cool about maths is that there's often more than one road to the same destination. And yeah, the official mark scheme actually has a whole other valid method. So the first way we did it, we connected x to the ratio right from the get-go. This other method, it kind of flips that. It starts by inventing a new variable, let's call it y, to represent one part of the ratio, and then it connects it all back to x right at the very end. Let's give this a quick run through. So you say one part is y. That means red is 3y, yellow is 5y, so bag A is 8y in total. Bag B is half of that, so it's 4y. Add them together, 8y plus 4y gives you 12y. Now here's the clever bit. We have to link back to x. The question told us red counters were x, so 3y equals x.
That means y must be x divided by 3. You just plug that back into your 12y, and what do you get? 12 times x over 3, which is 4x. Same answer, totally different route.
And yup, you can see the mark scheme gives full credit for this approach too. And that's a really important thing to remember. It's not about memorizing one rigid method. It's about showing your thinking is logical and correct no matter which path you choose. So there you have it, 2 totally different ways to get to the same correct proof. And both of them came down to one crucial skill, being able to translate a bunch of words into the clean language of algebra. The real lesson here isn't just about 4x, it's about strategy. So next time you're faced with a big, wordy problem, don't get intimidated, just see it as a code that's waiting for you to crack.